August 31st, 2022. A Super Hornet catches fire mid-flight over the Mediterranean. The pilot lands on the USS George H.W. Bush, but the damage is catastrophic. Normally, this jet would be craned off and sent home, out of action for months. But 33 days later, that same aircraft was flying combat missions again. The Navy did something they'd never done before. They fixed it right there, in the middle of the ocean, while the carrier kept moving. No shipyard, no dry dock, just raw skill, spare parts flown in by helicopter, and a crew determined to prove what's possible when you're 1,000 miles from home. That repair was historic. But here's what most people don't realize. It's not the exception. Every single day, American aircraft carriers operate in some of the most hostile waters on the planet, and they can't afford to sail home every time something breaks. So how does a floating city the size of the Chrysler Building keep itself running when the nearest port is weeks away? The answer is a system so advanced, so carefully designed, that it turns every carrier into its own mobile shipyard. Introduction. An aircraft carrier isn't just a ship. It's a naval base, an airfield, a power plant, and a repair depot all combined into one moving fortress. With over 5,000 personnel on board, these vessels carry everything needed to survive and fight for months without touching land. And that includes fixing themselves. From patching hull breaches to rebuilding jet engines, the U.S. Navy has mastered the art of its sea repair in ways no other nation has come close to matching. But it wasn't always this way. The Navy learned these skills the hard way, through fires, battle damage, and close calls that nearly sank billion-dollar warships. Today, what they've built is nothing short of extraordinary. If you've got respect for the men and women keeping these ships running in the toughest conditions imaginable, type proud in the comments below. The Damage Control Foundation. Every sailor who steps aboard a carrier goes through damage control training. It doesn't matter if you're a cook, a pilot, or an engineer. You learn to fight fires, stop flooding, and patch holes. Because when you're hundreds of miles from the nearest help, everyone becomes a first responder. The ship is divided into repair zones, each with its own dedicated team. Repair Party 2 covers the forward third of the ship. Repair Party 3 handles the aft section. Repair Party 5 is stationed in the engineering spaces, ready to deal with power and propulsion emergencies. And Repair Party 7 exists only on carriers, dedicated entirely to the flight deck and island structure where aircraft operations happen. These aren't just firefighters. They're welders, electricians, pipe fitters, and structural specialists. They carry equipment to seal ruptured fuel lines, shore up damaged bulkheads, and restore watertight integrity while the ship is still under threat. The Navy's damage control doctrine comes directly from World War II. At the Battle of Midway, the USS Yorktown took 3 direct bomb hits. Her crew patched the flight deck in just hours, getting aircraft back in the air while fires still burned below. She stayed in the fight. That kind of resilience became the standard. In 1967, the USS Forrestal suffered one of the worst carrier fires in history. A rocket misfired on deck, triggering a chain reaction of explosions that killed 134 sailors and nearly destroyed the ship. The crew fought for hours, throwing live bombs overboard by hand, flooding magazines to prevent total loss. Forrestal survived because her sailors refused to let her sink. The Navy turned that tragedy into a training revolution. Every recruit now watches footage from that fire. The lesson is clear. Damage control isn't optional. It's survival. Today, carriers train constantly. Dual carrier exercises bring crews from different ships together to share techniques. They simulate fires, floods, and battle damage while still pierside, so when the real thing happens at sea, muscle memory takes over. Self-sustaining repair capabilities. Carriers don't just react to emergencies. They're built to fix themselves as part of daily operations. The supply department stocks thousands of spare parts for both the ship and its aircraft. Everything from valve components to electrical wiring to hydraulic pumps. If something breaks, chances are the replacement is already on board. The Aircraft Intermediate Maintenance Department, known as AIMD, is basically a flying factory. It provides industrial-level repairs for the Air Wing's jets and helicopters. Technicians can rebuild engines, replace damaged airframes, and overhaul avionics systems without ever leaving the ship. It's the kind of work that would normally require a dedicated shore facility, but carriers do it while underway. Then there's the engineering department. These are the people who keep the nuclear reactors running, generate all electrical power, and maintain every system that makes the ship livable. Freshwater production, air conditioning, sewage treatment, heating, phone lines. If it involves power or plumbing, engineering handles it. And when something breaks in the middle of the Pacific, they fix it with whatever's available. The maintenance management department coordinates everything. They schedule repairs, prioritize work, and make sure the right people and parts are in the right place at the right time. It's a logistical ballet that never stops. But even with all this capability, carriers can't carry everything. That's where the next piece of the puzzle comes in. What happens when a part isn't on the ship? When a piece of equipment fails and the spare isn't in storage? Most people assume the carrier has to turn around. But the Navy has a solution that's been perfected over 80 years, and it happens while both ships are moving at full speed. Underway replenishment. It's called underway replenishment, or unrep. Two ships pull alongside each other, just 150 feet apart, traveling at 12 to 16 knots. Cables stretch between them. Then fuel, ammunition, food, and repair parts start moving across. The system was born in World War II. The Pacific theater was too vast for carriers to keep returning to port. The Navy developed a way to resupply task forces while they stayed on station, striking Japanese targets for months without pause. Admiral Chester Nimitz pioneered the technique, and it became America's secret weapon. Enemy fleets had to retreat to resupply. American carriers just kept coming. Today's UNREP system is called STREAM, Standard Tension Replenishment Alongside Method. A ram tensioner keeps the highline wire tight between the ships, adjusting automatically as they rise and fall with the waves. Pallets of cargo ride on trolleys that zip back and forth. A single rig can handle loads up to 8,750 pounds. Before we go further, take just a second to hit that like button and subscribe. Over 98% of you watch without subscribing, and it costs you nothing but makes a huge difference to us. Thank you. Supply ships like the Lewis and Clark class TAKE vessels are designed specifically for this mission. They carry ammunition, fuel, repair parts, and supplies, operating independently for extended periods. When a carrier needs something, they rendezvous, pull alongside, and start the transfer. The whole operation can last up to 5 hours. And it's not just parts. Personnel move too. If the carrier needs a specialist, a technical expert can be flown out by helicopter or transferred by highline. When USS George H.W. Bush needed to repair that damaged Super Hornet, Fleet Readiness Centers sent engineers, tools, and replacement components directly to the ship. No port stop required. Modern carrier strike groups can stay at sea for 100 days straight thanks to UNREP. Fuel gets topped off every few days. Food comes in weekly. Critical parts arrive as needed. The carrier never has to slow down. The Super Hornet breakthrough. That brings us back to January 2023 in the USS George H.W. Bush. The Navy had never attempted to repair this complex at sea before. The Super Hornet's fire damage was extensive. The 68R door skin, the S-11 skin panel, the starboard engine bay, and all the surrounding hardware were scorched and warped. Standard procedure would have been to ground the jet for the rest of the deployment. But the carrier's maintenance officer and the Air Wing commander had a different idea. What if they could fix it right there? They contacted multiple fleet readiness centers back in the States. Engineers reviewed the damage reports and started planning. It took over 3 months to coordinate, but the answer came back: it's possible. The Navy flew out technical experts. Parts and specialized tools came by helicopter. Then the real work began. For 33 days, technicians worked around the clock. They removed damaged sections, fabricated replacement panels, and rebuilt the engine bay from the inside out. Every step had to be done to exact specifications. One mistake could compromise the aircraft's structural integrity. On January 9th, the repairs were complete. The jet was cleared for flight operations. It rejoined the squadron and kept flying combat missions. The success proved something the Navy had long suspected. with the right people, the right parts, and the right planning, they could do repairs at sea that were previously thought impossible. The commander of Carrier Air Wing 7 called it a springboard for returning even greater repair capability to the fleet. It wasn't just about one jet. It was about changing what the Navy believes it can accomplish when operating far from home. The challenges they face. But let's be clear. These at-sea repairs come at a cost. The system is under enormous strain. According to a September 2024 Government Accountability Office report, the Navy is short nearly 84,000 enlisted sailors. That's not a small gap. That's entire air wings worth of manpower missing from the fleet. 63% of executive officers surveyed said completing repairs while underway is moderately to extremely difficult. Not because the work is impossible, but because they don't have enough hands. Engineering departments, the ones responsible for the most critical maintenance, are often staffed with the least experienced sailors. The skilled veterans are stretched thin, picking up the slack, and many burn out and leave for civilian jobs that pay better. Training is another problem. Sailors are arriving on ships without the in-depth, hands-on experience they need. Troubleshooting skills are weak. When something breaks, newer crew members struggle to diagnose the problem, let alone fix it. The more experienced sailors end up doing double duty, teaching while repairing, which slows everything down. Parts shortages add another layer of complexity. The Navy's aircraft carrier community created a working group to address supply chain issues, but those solutions haven't been shared fleet-wide. Each carrier is essentially solving the same problems independently, wasting time and resources. And then there's the pace of operations. Carriers are deploying longer than ever. 7 months used to be standard. Now, 8 and 9 month deployments are common. The USS Dwight D. Eisenhower just wrapped a 9-month deployment in the Red Sea, battling Houthi attacks on shipping. The longer a carrier stays at sea, the more wear and tear it accumulates, and the longer the maintenance period when it finally returns. USS Gerald R. Ford deployed for 8 months and came back needing a full year of repairs. USS Nimitz spent over a year in maintenance after extended operations. The cycle is brutal. The fewer carriers available, the harder the remaining ones have to work, which leads to longer repair periods, which keeps even more carriers out of action. The bigger picture. Despite these challenges, the U.S. Navy's at-sea repair capability remains unmatched. No other nation operates a fleet with this level of self-sufficiency. Chinese carriers still rely heavily on port infrastructure. Russian vessels lack the spare parts networks and trained personnel to sustain extended operations. The Royal Navy has capable ships, but far fewer of them, and they face similar manpower shortages. American carriers can go anywhere and stay there. They've operated continuously in the Middle East for years. They patrol the Pacific, deterring aggression near Taiwan and the South China Sea. They surge to crisis zones within days and remain on station for months. That flexibility exists because of the repair systems built into every aspect of their design. The lessons learned from World War II, from Forrestal, from Midway, from decades of hard experience, have created a culture where self-reliance is expected. Crews don't wait for help. They solve problems. They improvise. They keep the ship running no matter what. And now, with the Super Hornet repair proving that even major airframe damage can be fixed at sea, the Navy is expanding what's possible. Engineers are working on ways to pre-position repair materials in forward operating areas. They're using simulations and AI to predict what will break and where, so parts and tools are ready before the failure happens. Deployable repair detachments are being tested, small teams of specialists who can fly out to a carrier and handle complex jobs that would normally require a shipyard. What it means. Here's what it all comes down to. When an aircraft carrier is at sea, it's alone. There's no tow truck, no repair shop down the road, no calling for backup. The ship and its crew have to be completely self-reliant. And they are. From the damage control teams standing ready to fight fires and floods, to the supply personnel managing thousands of parts, to the engineers keeping reactors running, to the flight deck crews fixing jets under the open sky, every person plays a role. It's a level of teamwork and competence that most people will never see. These aren't just sailors doing a job. They're keeping a billion-dollar warship operational in conditions that would cripple most organizations. They're welding hull plates while waves crash over the deck. They're rebuilding engines while the ship maneuvers at high speed. They're doing it with fewer people, less time, and more pressure than ever before. And they're doing it because the mission demands it. That's what makes the US Navy different. It's not just the technology. It's the people who refuse to quit when things break. The ones who figure it out, make it work, and keep the ship in the fight. Conclusion. The ability to repair aircraft carriers while still at sea isn't just a nice feature. It's a strategic advantage that no amount of money can buy. It's built on decades of experience, countless hours of training, and a culture that values self-reliance above all else. When a carrier can fix itself 1,000 miles from the nearest port, it changes the entire calculus of naval power. The challenges are real. Manpower shortages, training gaps, and supply chain issues are putting strain on the system. But the foundation is solid. The doctrine works. And as the Super Hornet repair proved, the Navy is still finding ways to push the limits of what's possible. If this video gave you a deeper appreciation for what these crews accomplish every single day, hit that like button and subscribe. And drop a comment letting us know what impressed you most. We'll see you in the next one.